everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week we're talking about the outage trends we've seen in the first half of 2025. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Agile development has resulted in improvements in the speed of code delivery, but in some cases it may have inadvertently created organisational silos where developers become experts in their particular domain but fail to understand the impact of code changes on the wider environment. Can you explain the impact this might have?
So we talk about agile development. We've come from this process where we had like a waterfall development. So everything was done, the features of a single application tree, and we sort of pushed that code out twice a year, maybe we went there. So now what we've done is we've split all these areas up. We've gone from this monolithic architecture to this distributed modules effectively, and we're making these changes. So we can do this because we work in this one area, we're experts in that domain, we're making a change to that system. But what happens then is if we make a change or we make a tweak to our environment, we have to then understand when we push that code, what the impact is going to have on the overarching system. What else is going to be impacted on making this change? We start to make sort of very small tweaks as we're concerned to try and improve that element. We have this theory of actually sort of maybe pushing a bottleneck to somewhere else. Or again, coming to one of these cascading situations. Now, on top of this, what we have this situation is when we're doing this development in this one area, and this could be to put some sort of patch in place or to make a change, make a feature request or a feature change to this particular lump of code we're working on. What happens then is when we push that, we're unaware of the impact it has on the entire service delivery chain. So you have to have some holistic perspective over the end-to-end system to understand, I'll make a change here and it affects this area here. The quicker you can see that, the quicker you can sort of roll it back. So if I see a change and we've made something there, it might actually be, if we're thinking about sort of how things cascade down this system and how we're acting on this highly distributed environment, and we need to make a change to database optimization, propagate as quickly as possible. If we don't catch it early enough, we can effectively sort of make a simple rollback situation, which might take sort of a few seconds to do once we identify it, to having to sort of back out the whole world effectively, where you have to sort of stop and retrace the steps you've done because it's propagated so widely, so quickly. So the key to all of this is, again, we have this expert in this one area, but you need to understand the overall implications to an end-to-end system. And that includes all these third-party dependencies. Because also we can have this situation where we're relying on some third party, we have make an API call to it, they might make a change into their environment. And it may be something where they're having to change the quotas or they're making some change to a back-end system there. All of a sudden, we're making a request for information that now exceeds a timeout on a load balancer. So then what happens then is we have some sort of shutdown situation and we have a functional failure occurring.
Are third-party changes harder to deal with?
Yeah, absolutely. You have no control. You might have a contractual obligation with these people or contractual arrangement with these people, but they're not obligated to tell you necessarily we're making a change. And some of these are effectively done by their DevOps people. And again, you've got modules and modules and modules. You're making a call to service that might have multiple services in the back end. You don't know what's happening there. But what I do need to understand quickly is where is that fault or where is that processing delay or where is that performance degradation occurring? Because then I can take steps to either sort of back it out or not trusted information, or even start to build in processes. We're going back to that, building in the automated resilience, right? I see a delay at that point. I want to go to another server or another system or another back-end process to fill in the information, or ignore this step, skip that, and we come back to it. Whatever process is required to get around that. But key to it is identifying where that degradation or that performance impediment is actually occurring.
We've seen several outages in early 2025 where all of the outward signs suggested everything was running normally, but there were big problems under the surface. Why are issues like these particularly challenging to detect?
Because from the face of it, it actually looks like everything's actually running normally. So the first instance you're going to go to is if you have a particular issue yourself, you're maybe going to go to a status page to understand what's happening. If it's looking at one isolated function within that, it might be showing degradation, or it might even be saying everything's green. I'm looking at my environment, everything's there. So what we're going to look at there is to actually have users to make the complaint. But by that time, like I said, we could have propagated a change that's impacted. We could have had a situation where everyone's down, but they're just not actually using it. We're looking at this situation where it's functionally not available, but people don't know because they're not using that particular function. So you need to be able to understand what's occurring there. It also this situation where it all looks, everything's good on the surface, but I don't know it's happened till I specifically execute one portion of it. Or it might be that this is then latency sensitive. We think about a situation where we have something like auto scaling occurring in the back end there. This then might manifest in a way where we start to have a degradation of service because the timeout to the back end service goes there because it's load issue. So then we're going to think, we're having a load issue, it's just going to wait and make the request again from that point of view. But again, all my services at that point are going to show green lights across the area. It's only when I put those signals together that I can say, okay, I have a green here, I have an orange here, I have a yellow here. And when I put them together, that means that this function is not usable. So something like I'm actually making an authorization request, or I'm actually querying something in a back-end database, or I have a search functionality within there. That renders the whole application unusable because I actually can't use that function. But for all intents and purposes, it's all up. So it can be highly resilient. It's 24/7 available, but it's actually not usable.
So how do you go about detecting those issues?
What you need to do is to be able to understand the issues occurring by looking at that service from a holistic perspective, looking at that entire service delivery chain, understand those dependencies that come into place. What you need to understand is how that service is actually linked together. And you need to look at that from a proactive perspective. So I need to understand, without any user data being on top of there, how those systems are linked together. What I expect to be those performance metrics that indicate if I hit these gating factors at each of these potential bottlenecks or aggregating points, I'm actually seeing what I expect to see in terms of the metrics. Now, that could be a low loss rate. It could be a latency figure. It could be number of components I'm loading on a page. But it's only then when I actually view each of those in the context together from a proactive perspective that I can understand there's something happening here. It's a little bit looking like at the signals to understand the breadcrumbs. We're looking at the echoes of an effect. We want to see what would happen if the traffic actually traversed through this path, linking all these parts together. So we can see these breadcrumbs, we can identify what's going on, and we can go, spot the difference. This is different to this one. Therefore, something's not quite right there. So the real key to that is again, understanding how all my components are linked together, how they need to interact together, but also the performance they actually need. It's no good just having availability. They need to be performing within that threshold limit for the whole system to work correctly.
You've covered several outages this year with cascading effects, where the failure of individual components have had ripple effects across a network. How do you spot the early signs of these cascading issues? And what should companies be doing to prevent them?
It actually depends where it happens within that service delivery chain. So if it's happening on, again, this third-party system, it's going to manifest itself in different ways to different applications, at which point they actually need to make the call to that service. So the first thing I need to do is to actually understand, I've got to find that commonality. So where is the commonality between those? Because it's going to manifest itself differently in each case. So again, we'll look at the GCP outage. If I'm actually looking at it from one application's perspective, it sort of showed up as bad gateways. I actually couldn't reach that backend service. But in other ways, because it was actually failing at that authorization layer, as it were, it understood who was making a request. It just didn't know what they were authorized to do. So in that case, it manifested itself as a 400 error. It didn't know what they were allowed to do. So it actually came back with that particular error to stop things happening. So what we then need to do is say, what is the common factor in there? So where are we actually looking from that? And this is then we come down to a single aggregating point. So you sort of understand where that aggregating point is and then try those hypotheses against each one of those. Say, yep, okay, this is where it is. This is where we're going, the common one. Now, if actually looking to prevent that, it really then comes down to understanding, again, that entire service delivery chain. So where are my commonalities within that infrastructure? Some of these I might be able to sort of design around. So I might be able to have sort of multiple CDNs, or I might have another service I could actually call in the back end. I might have sort of replica databases, these types of things to do that. Once I've understood where that commonality is, I might be able to design around it. If I can't design around it, what I need to be able to do is then to identify when that degradation is occurring at that particular area there. quickly come down to the fact that it is this common point I'm actually looking at within that system. Is it within my control? Yes, it is, or no, it isn't. These are the steps I need to mitigate that. I can actually work around that. And it may be in some situations where it is, we actually can't do anything about that. It's out of our control. We've taken the risk to actually do that. So we need to therefore override a system or make sure we're actually using that. Now, the example I'm thinking of there, so I'm looking at it from some sort of agentic perspective. So I've actually have some sort of cascading. It's failing in different times. We have an agent that's using a common agent everyone's using, and it's actually a failure occurred within that load balancing situation where I'm actually trying to reach that agent. What's going to happen there is going to manifest itself again in different ways to different organizations. Now, the failure, how I deal with that, once I've identified that I actually have some sort of performance failure or some sort of issue getting to there, I need to be able to make a decision. Because if that is some sort of critical component in terms of information that I need to make the next step, then what I need to do is to be able to override that manually to say, okay, the information we're now making our decision on is potentially flawed. So therefore we can't go on, rather than just kind of ignoring it and have that situation. So what I'm getting to that is really when we need to think about what we're doing from that service delivery chain, not just from an infrastructure perspective, not just how the components are linked together, but how the application that we're actually using or how the service we're using on top of those needs to interact and how that it operates. Because that then from an architectural perspective really starts to come into this overarching thing. And we could potentially design around either fail-safes within there or workarounds within the application. So we're starting to make these changes at an infrastructure level from an automation perspective, but also start to consider how that's going to impact the application architecture as well.
Just as in 2024, configuration-related outages have continued to be a theme in 2025. Tell us more about that.
This is on a similar theme to the Agile development process. So whereas in that case, we're doing sort of code change and pushing it, at this point, we're making configuration changes to each of those systems, but it has the same type of effect. So we make a change to a configuration system that has a flow-on effect to another system, which has a flow-on effect to another system. It's only when they all interact together that we start to see these problems. So what we need to do, again, is to be able to understand that service as a whole to see where each is changed. You don't necessarily need to understand a configuration change has been made, but just that something has happened and this is now the domain where that issue is occurring or where that degradation is occurring. So therefore, we can actually mitigate around it.
We've also seen a trend of disruptions caused by back-end issues, with three major categories of back-end outages emerging. Can you outline those for us?
Yeah, when we think about a back-end service issue, it's quite easy to say. It's something that's happening. We can get to the front door of a service. We can get to the CDN. We can get to the actual server itself. We can maybe even authenticate. But what we can't then do is to communicate with the back-end, so we can't get it out from there. So the first one of these is what I'm going to call Schrodinger's outage. So this is that outage essentially where you only know it's down when you actually look at it or start using it. So you don't know it's state until you actually go into that. So if we think about the Slack outage that occurred on May the 12th, this is a really good example of that. If you were to look at Slack, you were to go into that system, everything seemed up and functioning. It was only when you tried to interact with it to send a message or to query something else when you actually started to see that there was a problem on it. So at that point, again, if I'm actually looking at each of the areas, I wouldn't have necessarily gone to identify what was wrong because I wouldn't have thought there was an issue. So I wouldn't have gone to a status page to see there was a high issue from there. So these are these outages which actually, for all intents and purposes, look like everything's functioning normally, but it's in that back-end system where there's a problem, but it's not manifested itself until you actually start to interact with it.
What's number two?
So the second type I want to talk about is intermittent back-end failures. So these are where we have sporadic issues in the back end, but they're not big enough essentially to take a whole system down. So they result in like a lagging performance. So people are not complaining enough because they can still use it. So they're not actually looking for an issue, but it's actually kind of slow. And these manifest themselves in like sort of slow page load times, or I might get a refusal the first time, I then press return again, and I get the sort of whole page loaded. It just appears sort of slow. But these are kind of difficult to spot because they're intermittent around there. Microsoft 365 had an outage on May the 6th, which sort of looked like this. So the page load times that we saw throughout disruption were sort of going up and down, and it was resulting in intermittent connection issues. So it impacted one particular region, which is being sort of North America, while the others remained stable. So if I'm looking at this from an overall surface, I'm seeing no problem whatsoever. It's just me as a user going, it must be me, it must be a local environment from there. So it's actually understanding what's happening. So we can see it in that way, or we can also start to see it in this back-end load time, basically. So we sort of see these bad gateways or service unavailable types of errors coming through itself. So they indicate the back-end service issue, but we're not necessarily sure what it is. Again, these can be load related. So it could be that a service is timed out in the back end, or it could be that it's actually not reachable because there's some sort of network issue. But the fact we're starting to see a signal come back from our front end, essentially, where we've actually made the request and it said, I'm sorry, I can't reach that service. We know then that the front end is actually functioning. So we can actually rule out the network. We can rule out a local environment. We know we're starting to get that performance there. But again, these will sort of appear as intermittent because sometimes I'll get through, sometimes I won't. In that case is where we normally attribute it to some sort of congestion in the back end. It could be something like a load balancer configuration change. It could be that there's sort of maintenance or service window going on. So what's happening is we have some sort of back-end service which isn't available. Or it could be some other external event that's actually generated a lot of traffic to that environment where we're then starting to have these effectively congestion in the back end itself.
And what's the third type?
So the third type of these are functional back-end failures. So this is where some entire function itself failed. So it might be calling a particular service or trying to retrieve a particular part of information that is required just for this one function on it itself. Now, in some cases, it makes the application unusable, but it's easier to spot than the Schrodinger's outage because it identifies itself effectively as some sort of error whilst that service component is actually loading. So it might be that we start to see some sort of 503, some back-end reachability types of issues there. Bad gateway, can't get to it itself, but it's actually one particular area and it's consistent. Whereas the intermittent back-end failure, the 502s, 503s will come and go because through some windows of opportunity, I'm able to have that connectivity where in this case, it's hard down effectively for that one function.
Thanks for that overview of the themes we've seen in 2025 so far. What about the first half outage numbers? What are we seeing there, Mike?
So from January to June 2025, the percentage US network outages declined from 55 to 39%. Now, the US outages peaked early in the year, while the global outages increased from 1,382 in January to 2,110 in March. US outages rose by 23% from January to February, but growth slowed to just 11% in March, which compared to a 32% increase in global outages.
Having seen that big surge at the start of the year and then the slowing down for the Northern Hemisphere summer, when do you typically expect outages to start climbing again?
So historically, we've actually sort of seen it sort of climb towards the September, October as it starts to sort of come up to that area there. Now, it's difficult to directly attribute exactly what they are without sort of going through all the maintenance and the engineering stuff. But typically, we can tie this into work being done on a system, and we can do this by allocating time a day and those types of things there, which has gone, like I say, hand in hand each end of the year. So this is what we're normally seeing, is we see this slow down for all regions, and then it starts to sort of pick up as we then come into the back end of the year.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode is published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions or feedback to internetreport@thousandeyes.com. Until next time, goodbye.